Hello everyone, welcome back to our channel. In this video I will provide a passing package on DDCO. First I go with third module and first question is what is addressing mode? Explain different types of addressing mode with an example. Second question is explain 4 types of operation performed by computer with an example. Explain the basic types of instruction formats to carry out C10 A plus B. Third question is with a neat diagram, explain basic operation concepts of computer. Fourth question is explain bus structure with diagram, explain how different peripherals is connected to bus. Fifth question is describe big endian and little endian addressing assignment. Sixth question is explain branching operation with using a loop to add n numbers with block diagram. Seventh question is illustrate an index addressing mode with assembly language program to find sum of test 1, test 2 and test 3 score of n number of student. Eighth question is describe the following. In that processor clock, basic performance equation, clock rate, spec rating. Ninth question is write a note on, in that, register transfer notation RTN, and assembly language notation. TGen. Next I go with fourth module. In that first question is with a neat diagram, explain the concept of accepting I/O devices. Second question is what is bus arbitration? Explain centralized and distributed arbitration methods with a neat diagram. Third question is with neat sketches, explain various methods for handling multiple interrupt requests raised by multiple devices. Fourth question is what is cache memory? Explain any mapping function of cache memory. Fifth question is explain the following with respect to interrupts with diagram sad face I, vector interrupt E, interrupt nesting E, simultaneous requests. Sixth question is explain direct memory access DMA, with a neat diagram showing registers and controllers. Seventh question is explain the effect of size, cost, and speed in the memory hierarchy. Eighth question is explain hardware interrupt enabling, disabling of interrupts and the sequence of events in handling an interrupt request from a single device. And next I go with module 5. In that first question is draw a single bus architecture and write the control sequence for execution of instruction ADD R3 R1. Second question is with a neat diagram, explain the concept of register transfer and fetching of a word from memory. Third question is with a neat diagram, explain the flow of a 4-stage pipeline operation. Fourth question is explain the role of cache memory and pipeline performance. Fifth question is draw and explain the single bus organization of the data path inside a processor. Sixth question is analyze how does execution of a complete instruction carry out. Seventh question is explain the process of fetching a word from memory in a processor. Eighth question is describe how a loop performs arithmetic and logic operations along with a proper diagram. Next I go with first module. In that first question is demonstrate the positive and negative logic using AND gate. Second question is show that NAND and NOR function are commutative and but not associative. Third question is simplify the Boolean function f of x, y, z is equal to sigma m of 0, 1, 2, 4, 6, 7, 9, 10, 14 using k-map and implement using NAND gate. Fourth question is apply k-map technique to simplify the function in that f of x, y, z is equal to sigma of 0, 2, 4, 5, 6, then f of x, y, z is equal to x dash y plus yz plus y dash z dash, then f of w, x, y, z is equal to sigma of 1, 3, 7, 11, 15 and d of 0, 2, 8. Fifth question is describe map method for 3 variables. Sixth question is determine the complement of the function f is equal to xyz plus x dash y, then f is equal to xy plus xz and then f is equal to x dash y dash z dash plus x dash yz. Seventh question is obtain a minimum product of sum and sum of product carry of full adder using k-map refer the MQPs and PYQs. Eighth question is determine all the prime implicant for the Boolean function f and also determine which are essential f of x, y, z is equal to sigma of 0, 2, 4, 5, 6, 7, 8, 10, 13, 15. Ninth question is state and prove De Morgan's theorem for 2 variables using truth table and list the postulates and theorems of Boolean algebra. Lastly I go with second module. In that first question is design a half adder and full adder circuit, also develop data flow model for both. Second question is briefly explain 4-bit parallel adder and design a BCD to XS3 code converter. Third question is explain look ahead carry adder. Fourth question is explain decoders. Explain 8 into 4, 3 into 8 decoders. Fifth question is explain encoders. Explain 4 into 8, 8 into 3 priority encoders. Sixth question is explain multiplexers. Explain 2 into 1, 4 into 1, 8 into 1 mux. Seventh question is what are storage elements. Explain the working of SR and D latch using logic diagram and function table. 8 question is explain master slave JK flip-flop with logic diagram and truth table, and lastly all the best for your exams, and if you any passing packages please comment below.